Hey everyone, welcome to another YouTube tutorial. I promise I'm going to be getting a new microphone pretty soon, so this low quality mic is just going to have to do for a few more videos, and then I promise we'll upgrade and we'll get some more consistent quality here. Okay, so I'm going to jump right into today's topic, and today we are going to be going over how to create dynamic character animations using code. Now, let me explain that in more detail by opening up the manual. And this video is really going to be going over one method that GameMaker Studio offers that I don't see a whole lot of people talking about, and that is asset get index. So let's go and open this up and see what does this do and how can we use it in GameMaker and why this is one of my favorite methods in GameMaker just overall, and I use it all the time, even though it's a little slow on the performance. So it's best not to overuse it, but it definitely has its use cases that have saved me, especially in game jams or I'm really crunched for time. So what does this asset get index method do? Well, okay, so we have our method here and it takes in a name. So the name of the game asset to get as a string. So what this does is this takes a string and it looks through our entire resource tree over here for an asset that exists in this resource tree with that same name. So if I were to put in the string oPlayer, it would return the object index for this. Or if I were to put splayer_idle_0, it's going to get this sprite asset here and it's going to return it to us. So I'm going to show you guys how to use this and how we can implement this in our project. But first, let me show you one of my other projects that I've used this in recently. And I can explain why this is so great for doing character customization or for having like a character select screen where the player can play as multiple characters, and how you can use this to save yourself having to write a whole bunch of code. You just kind of write this one method and you get this dynamic control over all of your sprites. So let me go ahead and show you what I have here. So this is the most recent Ludum Dare game I did for Ludum Dare 43, Sacrifices Must Be Made. Go check that out on my itch page if you want to play it. But here you can see that I have 4 different characters. So I'll go ahead and pull them up. So here's this one guy, here's another one here, another one here, and another one here. So what I want there to be is I want there to be player objects in the scene that run around, but I want those all to have an idle, a run, a jump, a hurt, and a kill animation, but I want the player to be able to choose which Aztec is what these little characters are, which one of these little characters, these little Aztecs that they get to play as, but we're only using one line of code to draw these sprites, and it is knowing that based off of the character that the player chose from the character select screen, how to draw this. So if I go ahead and run this, oops, we're running on Windows, stop, please stop. Let me go ahead and run this. I will show you the character select screen and how this looks, and then I will show you the code, and then we will go over a real quick project on how you can implement this very easily into your projects. Okay, so perfect. So I'm gonna go full screen here. And let me mute. Okay, so here you can see that, oh no, it's, go back. How do I go back? Ah! Okay, here we go. So here, when I come to my character select screen, I can cycle through all of these characters. So keep in mind, I'm using this asset get index method for this character select screen, but then once I select the character and jump into a game, so here, let's go ahead and jump into the game. You can see that my player 1 down here is that character that I selected, and I'm able to run, jump, I'm able to pick up things and throw things around. And all of these other players running around are also just one player object that randomly picks its sprite, and then it is able to move and interact and use the appropriate sprites based off of just a simple variable that changes. So we're going to go ahead and see how that works here, and then I'm going to go over how we can implement this in our project. Okay, so we have all of our sprites, and if you notice, they follow a format. So it's really important for this that you use consistent formatting in your variable names or your asset names, because this is going to become really easy to use if we have a same format. So you'll notice that every single one of my Aztec sprites here follows the same format. It's S for sprite, and then it's AZ and then some number underscore their animation. So this AZ1, 2, 3, 4 represents the different type of Aztec characters. Now this is going to become crucial for this to work. So let me come down here to my objects, and I have just one player object. You'll notice I don't have 4 different player objects for each sprite. I only have one player object. I'm going to go ahead and open this up, come to my create event, and then let me zoom in here. And I apologize for the poor quality. GameMaker hates doing any sort of anti-aliasing with this. Okay, so you'll notice that here, if I look at what my sprites are, so this is in my create event of my player, okay? So you can ignore all of this other stuff. This is totally out beyond what we're working on. This is just my other code for the game, but I want to show this in application. Okay, so here you can see that I'm defining 5 different sprites: an idle, a run, a jump, hurt, and an alter. And this is the kill sprite. I didn't name it consistently, so that was my fault. And you'll notice that I'm using this asset get index, and then I'm doing some kind of weird stuff in here. So remember that asset get index just takes in a string. So what I'm doing is I'm doing some string concatenation here based off of a variable to define what my sprites are going to be. So you'll notice that I'm taking s and then I'm adding it to this string value of the name variable, and then underscore idle. Well, name is, if we come back to my code here, you'll notice, okay, name is empty, but when we define the objects, sorry, I'm going to be all over the place for just a second, and then we're going to bring it all back around. So here you can see that when I'm instantiating these objects, I'm giving them a name. So here their name is AZ plus some sort of value. And if they're a computer player, which is this here, it just randomly picks 1, 2, 3, and 4. So we're just randomly picking, is this going to be the Aztec 1, 2, Aztec 3, or Aztec 4? And we're building that into a name. So this name is going to be AZ1 or AZ3 or AZ4 or whatever. Okay, so that's the name value that we're giving to our objects. And then when we come back into our create event here, you can see that asset.index, get index, is s plus our name plus idle. So it's going to look something like s az1 underscore idle. Okay, and that's what our string is going to be equal to. Is going to be equal to something like this. Now, this is not real code. I'm just I'm just demonstrating this, that this string value is going to be equal to something like this, or maybe it'll be equal to saz4 underscore run. And what that is going to do is it's going to say asset get index of this string. It's going to look inside of our resource tree for some object, for a room, for a sound effect, for a sprite, anything that could exist in our project that has that same name. And here you can see that saz1 underscore idle exists as a sprite, and now this idle sprite variable is going to be holding that. So all we have to do is to change these sprites is just change this name variable, and it's going to automatically populate these variables with these sprites from here. And then if we go into our draw event where the sprite is actually getting drawn, here you can see that I'm just using a state machine I'm just saying, okay, when we're in the idle state, just draw the idle sprite, draw the run sprite, draw the jump sprite, etc., right? So we're just assigning these variables at creation of these objects, and then that way every player object shares this same line of code, and we don't have to define separate code. Be like, oh, well, if the object is the Aztec number 2, well, make sure you draw the Aztec number 2 jump sprite instead. And we're not doing that. We're just doing one line of code that's just saying, hey, just draw the jump sprite, whatever that is. We'll deal with figuring out which jump sprite you should assign that to. Okay, great. I hope that makes sense. If it doesn't make sense, we're going to do a project right now where I show you how to do this, and then it's gonna make perfect sense. So let's go back to our project that I started. Now I have some sprites imported. I actually just released an asset pack for free, so if you want to download these assets and follow along, you can come to this link. I'll link it in the description down below. These are our sprites that I used from the Ludum Dare 39 a couple years ago, Game Jam, and I'll show you why we're using these sprites in a second. But if you go to this link, come to my page here, you can download these assets for free, and you can follow along with the video. Here's a video link to Jupiter Hadley's YouTube channel where she plays through them, and you can see some gameplay of what this game actually looked like. It's where I kind of snagged this GIF from, just to get an example of what these sprites look like in action. But if you want to follow along, download these and go ahead and import them into your project, and then we will get started. So now, why did I choose these sprites? Well, if you notice, I have 10 different variations of this idle sprite. I actually have 11, but this character has a little battery pack on his backpack, and it can drain down. So when we play this idle animation, you can see there's this little water kind of sloshing around. That's like his energy level. And each of these represents a different level for that water. So that water can be, or that energy fluid, whatever it is, can be filled all the way up to 10, or it can be completely empty. So if we go here, we see that there's nothing in this backpack. Now, I'm going to show you how we can use all 10 of these sprites to animate a character that uses this idle and this run animation with only a single line of code, just like how we did in the last project. So I have my room created, and I have my player object dropped in there, as you can see here. I'm going to add some basic movement code, and then I'm going to show you how to do that. So let me just go ahead and write some code here that is just going to allow us to move the player around. Okay. Great. So this is just going to allow us to move our character around real quickly around the screen. Okay. So let's go and run this, make sure that our project is building, looking properly, that we get some basic movement, and then we can actually start working on what we're going to work on here in a second. Okay, great. Here's our character. Why are you not doing anything? Keyboard, check. W. Oh, why is this not working? Oh, you know what? I think it is working. We just have no sense of reference in the room. So yeah, okay, there it is. I placed the object in the middle of the room, so, and the background is just this boring gray solid color. So we are moving, it just didn't look like we're moving. Okay, so here we go. Great, I have a simple moving around code and a camera following them. Nothing too crazy. Okay, so now let's do the cool thing. So I'm gonna come into a create event, and I'm gonna create a variable that's just gonna be called power level. And we're going to set this equal to 10. Okay, this variable is going to represent how much energy we have left in our backpack. Actually, let's just call it energy. Okay, so now what we want to do is we're going to create a couple sprites. So we're going to say idle sprite, and we're just going to set this equal to no one at first, and then we're going to say run sprite equal to no one. Okay, so these are just going to get instantiated to nothing. So now what we can do is we can come into our draw event. So let's create one. Let's go ahead and make sure we draw ourselves no matter what. But let's make some changes to our sprite index and our image index. So let's say that well, first let's add some other variables. Let's say image speed. These are just some, and yeah, I guess that's all I needed, right? Okay, so now we're going to say sprite index is going to be equal to, so what we could do is we could say sPlayer idle 10, and this would, so if you notice when we last ran it, we had 0 energy in our backpack, but if we run it now, we should have 10 energy in our backpack, right? Okay, cool. So we're setting our sprite index to a very specific sprite, and then we're drawing it to the screen. Okay, but what we want to do is we don't want to hard code this. We want to get this sprite from this tree based off of our variable energy, which is going to fluctuate and change throughout the course of the game. So we're going to change this, and we're going to say asset get index, and now we're going to build up a string that's going to represent our sprite name. So we know that every sprite starts with sPlayer underscore idle. And then now we know that this next part that comes after the second underscore is going to be our energy level here. So I am going to, end the string here, and I'm going to say plus, and then what we want to do is we want to add our energy variable. Now we can't just add it like this, because this is going to freak out. It's going to see that this is a string and that this is an integer, and it's going to try to add them together, and GameMaker is going to crash and freak out. So we just have to wrap this integer value in this method called string here, and that is going to turn this energy integer value into a string, and then it's going to add it to sPlayer idle. So let's go ahead and close out this bracket, and now we can see that we've created some string variable that's going to get added into this sprite index. So now if we run it again, we should still have, what did we instantiate our energy to? 10. So we should still have a full backpack, which we do here. So let's go ahead and change this. Let's grab this. Now this, like I said, asset get index is a very slow method. So we want to try to avoid putting it inside of a step event, inside of a draw event, something that's going to get called every frame. So instead of putting this here, we're going to go ahead and put this in our create event, and we're going to say idle is going to be equal to this, and run is going to be equal to sPlayer underscore run energy. Okay, and now inside of our draw event, we're just going to say our idle sprite. So let's go ahead and run it again, make sure that everything works. All right, everything is drawing, we're still looking good. So again, just to kind of go over why I did that, we only want this asset get index method calling whenever it's necessary, so we put it just once at the beginning of the create event, not every frame in the step event. We don't need that, or in the draw event, sorry. So now let's go ahead and create a couple more things. I'm just going to create a enum player state, and I'm just going to create two player states, idle and run. Okay, and I'm going to create a state variable, and I'm going to say this is going to be equal to player state dot idle. Okay, so when we start the game, our player is going to be in the idle state, and then we are going to say if keyboard check any key. So if we're pressing any key down, we are going to be state is equal to player state dot run. Else our state is going to be equal to dot idle. Okay, so if this doesn't make sense, we're just building a state machine. Go check out other videos on state machines if this doesn't make any sense. I will probably make one in the future, but here I'm just assigning a variable to keep track of the player's state and what they're doing so that we can then draw based off that state. Okay, so I'm just going through this quickly because that's not really what this video is about, but just to demonstrate some of the cooler stuff we can do, it helps to have this set up. So now if we're pressing any key, this player is going to be, it's going to just say, hey, we're running, we're moving around because we only have movement keys defined. And if we're not pressing anything, then we're idle. So great, let's do nothing. And when we start the game, we're going to start in our idle state. Okay, so now we're going to change this. We're going to turn this into a switch. Let's not do a switch statement. This is simple enough. We'll just do an if. And we're going to say if state equals player state dot idle. And then we're also going to check for, okay, so now we have these two state checks. So now if we're in idle, we want to say, sprite index equals idle sprite. And if we're in run, we want sprite index equals to run sprite. Now what's cool about this is if we wanted to add different image speeds, we could do that here too. So say we wanted to run really fast, 0.8, we could set a faster image speed there, and then here we could set a slower image speed for our idling. Okay, cool, so let's run this, make sure we're looking good. So now this should just transition between our idling and our running sprite. Okay, great, so here you can see when I move left, I'm running. When I move up, down, left, right, I'm running. But when I stop pressing any key, I'm idling. Now I don't have any facing. I could add, so that he turns and faces the direction we're moving. I'm not going to do that for this video, but you can see that now we have two different sprites being defined, our idle and our run sprite. I'm going to turn this run animation down, that is a little too fast. Okay. Cool, so now the last thing we're going to do is how can we change this, right? How can we change our energy level? So I'm going to come in here and I'm just going to say if keyboard check pressed, and I'm just going to say VK right arrow. So if I press the right arrow, I want to add 1 to the energy level, and if I press the left arrow, we're going to remove 1 from the energy level. Okay, so now our variable, we can start to change our energy levels just with some keyboard presses. Now if this was your actual game, you would probably do something like when the player gets hit, reduce the energy, or when the player picks up like a battery pack, increase the energy. These are the different types of things you would probably actually put in your game, but for debugging and just testing purposes and just showing you guys, I'm just going to map these to some keyboard inputs just to show that, hey, we can change the energy level, and when we do change the energy level, that changes our sprite. Okay, so let's run it. Actually, I'm going to stop this real quick. Let's draw some text to the screen so that we know so that we know what this energy level is. So I have a view set up in this room, so I'm just going to do a draw GUI. If you don't have a view, you could just use a draw, but this is going to map it to our view so that we're not drawing things outside of our view. So we're just going to draw, I'll put a little label, say energy plus string of energy. Okay, so now let's run it again. Okay, so now when I press the right key, our energy goes up. Oops, I misspelled that variable. Okay, let's energy, and then I'm going to make sure that our energy is going to be always equal to, we're going to clamp it to a minimum of 0 and a maximum of 10. So it can never be less than 0, can never be greater than 10. And I spelled all my variables right this time, I think. So now when I press right, it doesn't go up. When I press left, it goes down to 0. So now I can start to adjust my energy. Great. And when I press the movement keys, we start to run and we still have all of our sprites working. Okay, great. So we're looking good. But if you noticed, we didn't have any of our sprite changing based off the energy, right? The energy variable was changing, but our sprite wasn't changing. Like our battery pack wasn't filling up at all. Okay, now that is because we put this asset get index here in the create event. So let me show you. If I take this out and let's put this back in the draw event. So S player idle. Okay, this looks good. And then let's change this to S player run. So let's put this back in the draw event. Now the reason I'm putting back in the draw event is because it's going to update every frame, right? The draw event is just like our step event. So now you'll see that when I press left and our energy starts depleting, our backpack is actually depleting in energy also. So here we are with 1. And when I fill it back up, I can fill it all the way back up to 10. And if I deplete it down, let's deplete it down to 3, and then I start running around, you see that we're actually still running around with the backpack being down lower in energy. And it's not filling back up until our energy variable increases or decreases. Now, I'm probably going to stop the video here because actually I'm going to do one thing and I'll show you how to optimize this and the reason why I took this out of the draw event. So this is everything I wanted to cover in this video. Everything past this point is kind of extra credit. How do we program this and code this a little more properly? But this is everything that I wanted to show you. So using this method, asset get index, we can do dynamic animations like this, where we have some sort of backpack that is filling up. You can do multiple characters. You could do a character customization where you're drawing different sprites mashed up into one. Like I said in the last one, all I was doing was changing which Aztec number they were, and then I was defining an idle, a run, a jump, a kill, a whatever sprite based off of their Aztec number. And all of it was just using this string concatenation here to build these. So I'm going to now, let's go ahead and optimize this. So if you are done and you feel like you understand this, great, you can stop here. Otherwise, hang out with me for 5 more minutes as we update this. Okay, great. So how do we optimize this, right? Like I said, this asset get index method is slow, so we don't want to put it into an update method that's getting checked every frame. We only want to check it when we need to check it. Okay, well, when do we need to check, when do we need to update our sprites? Okay, well, we only need to update our sprites when our energy value is changing, right? So we don't need to check it every frame because our energy value isn't changing every frame, and we can't just update it at the beginning at our create event because then it never updates for the rest of the game. So we just want to update it whenever our energy variable is updating. So I am going to do that very easily. I'm going to I'm actually going to delete these. I'm going to come over to scripts. I'm going to create a script and I'm going to say update energy. And this update energy is going to take in one parameter and it's going to be amount. And we'll create var amount equals argument 0. And then we're going to say energy plus equals to amount. And then we're going to update our sprite indexes. We're going to say idle sprite and our run sprite. Okay. And now, oops, I did not want to delete that. Player idle. Okay. So here I am updating my sprites whenever I call update energy. So I pass in some parameter. This can be a positive or a negative value, and then our energy is going to be changed to that. So actually, let's grab this clamp variable and let's throw this clamp in here. And then we are going to then update our sprite. So first we want to say, okay, update energy variable, and then update our sprites that use the energy variable. Okay. So now we've updated all of those. So now all that we need to do is we just need to come up here and we say, okay, whenever we press the right key, we're going to say update energy, spelling, and then I'm just going to say we want to just add +1 to that, and then here we're going to say update energy -1. Okay, so now if we run it again, do we have the draws? Okay, yep, the draw is just drawing our variable. Oops, I probably misspelled something. Oh, we did not define those at creation, so let's put those back here. We can just set those to nothing. Now the reason we can set those to nothing is because our step event is going to get run right away. Oh, actually, we're gonna, if we want to do that, remember we're not updating our sprites variables ever until we call update energy. So we either need to define these the same way that we define these, which we could just do that. We could just copy these right down here, and that would be good to go. Or we could just do this like this, and then we could say update energy, and then we're just going to pass in a 0. So we're not going to change our energy variable at all, but this would then call our sprites and update those. Cool little trick we just created and we can do there. All right, so if I press left, our energy depletes, and if I press right, our energy increases, and we can move around and we get all of those sprites working perfectly. I was going to do something else. Oh yes, okay. So last thing I will show you is, that's it for code, but I am going to demonstrate the difference that this that using this method inside and outside of the draw event does. So let's go ahead and run our debugger. Okay, so our debugger is running. Now here, if you take a look at our performance over here, you can see we can analyze our memory and our FPS. Now here you can see that our FPS is in between, let's say, 6,500 and 7,500. So let's just say it's averaging about 7,000 frames per second. Okay? That's cool. So that's how we have it optimized. Now, let's unoptimize it. Okay, so we're going to put our asset get index variable inside of our draw method again. Now let's run the debugger. So we were averaging about 7,000 frames per second on average, a little bit closer to 6.5. If we come back over here, all right, so we're 6.5. Oh, we're dropping a little bit slower. So the lowest we ever saw before was 6,400. Here we're seeing 6,200 as our slowest. Oh, that was 6,000. So we're looking at 6,000 as our slowest. So, oh, there's 58. So, and our average is brought down a little bit. Now you might be looking at this and saying, okay, so what? No game runs at 7,000 frames per second. Yeah, you're right. This is such a minimal difference in performance. However, this is only one sprite that is using this method. And if one sprite using this method in their draw event can drop our performance by 500, almost 1,000 frames per second in this one, just this one sprite, calling it twice in two places, then imagine what would happen if we had 20 sprites or 100 or 1,000 on screen all trying to use this. We would start to hit a huge performance dip. Whereas by optimizing it the way that we did and only calling it when we update energy, we see a general improvement. And if we had more sprites using this, we would see a lot. Actually, let's test that out. How about this? I'm just going on a crazy tangent, guys. I'm going crazy. Okay, I'm just gonna drop a ton of players in here. 1, 2, 3, 4, 5. Let's do 10. 6, 7, 8, 9, 10. And I'm going to stop following the player. Okay. Oh, nope, don't run it. Let's go into the debug mode again. Okay, so let's come back over here to our FPS. So we have 10 objects in the room, and you can see now we've dropped down to all the way to 4,200 being the slowest that we've seen. Okay, so we're starting to see more drops in here, and that's just with 10 objects. So I'm going to stop it one last time, and the very last thing I'm going to do is I'm going to just redo all of our optimization changes here, and now you can see we're not calling it every frame. We are still just only calling it when we call update energy. So what were we at? We're like 4,200 was what we saw after a few seconds. And here we have 10 objects with more optimized code. We come back over here. And we're getting a little bit higher, but not much. So, okay, so I didn't see as much. I was expecting to see more of a effect. Okay, there we are. We're peaking up to 5,200. So again, about a difference of 1,000 frames per second. I was expecting that we would maybe see more of a, a larger growth or a larger difference between those two because we increased and grew the number of objects in the room that we're using it, but it doesn't look like it scales up quite to the level that I thought it did. So good learning moment for me, but also proves my point anyway that it's less performant to just have that called every frame. So this was a tangent with Alex. Thank you so much for hanging out, guys. I hope you found this video useful. Like I said, I will be improving my mic by purchasing a better mic, and I will be uploading more videos. I have more assets that I'm working on. A really cool one that I am almost done with, two really cool ones that I'm almost done with that are GameMaker systems, and I will be making videos for those and going over those soon. So thank you guys so much. I will see you in the next video.